Okay, hello everyone, and welcome to our session Outlook of Manufacturing Activities along the battery value chain in Europe at the Battery Innovation Days. I'm Marco Eberts from VDI VDE Innovation and Technik, and will be the moderator of this session. Just an FYI for you, in order to interact with our speakers, please use the Q&A or the chat function of the right side of the browser. And then after two presentations, we will have our first Q&A. In total, we have today 4 presentations. And just for the sake of time, let's dive into our first presentation held by Marko Kivisö from Business Finland. Marko is the head of industry cleantech invest in at Business Finland, where Business Finland building capital and competences to combat climate change in a sustainable manner. His work focuses on the investment development into clean, smart energy production, battery value chain, and hydrogen value chain into Finland as integral part of growing European industry value chains. And prior to joining Business Finland, Marko has over 25 years of experience in various leadership roles in global companies across several industries. So I'm really looking forward to your talk, Marko, and of course the stage is yours now.
All right, Marco, thank you very much, and for everybody. So I'm coming from Finland, and I want to give a little bit of perspective from the Finnish angle. And so our role here is to combat the climate change. So we see the batteries as one of the solutions here, and one of the main topics for us is the sustainability. And when we move on to the next slide, so that happy to report Finland being the #1. And also the colleagues from the rest of the Nordic countries. So in this way, we are also building, let's say, the Nordic battery value chain, and here we cooperate very much with others. But this is now one of the key topics when we have the discussions with the companies building the value chain. So sustainability, and from that point of view, Finland has been on the really leading front on this. So this is #1 topic and I'll cover a little bit about what's behind that one. So moving on to the next slide. So the Finnish overall the strategy here is that aim for the carbon neutrality by 2035. So that's in line with the EU target of 2050. And some of the key topics here is that one is that we will be cutting the coal out of the energy production. Oil consumption will be cut in half. But what is very pleasing is this is actually industry driven activity, and this is then very much also supporting the build-up of the battery industries, because we see also the battery industry, the large manufacturing, that's part of the, let's say, our energy system, for example, various, let's say, circular economy solutions. So we are looking this from the very holistic approach as a country. When we then move on, next slide please. So Finland actually is in a unique position. Electrification know-how, digitalization know-how, and then also we are the only country in Europe that having the lithium, cobalt, nickel in our soil, and based on that one also extensive know-how on the, let's say, the processing industry. We also process a significant amount of the materials coming from elsewhere, and through us then it goes into the European battery value chain. So this has actually enabled the companies and the research institutes to build a really unique, sustainable, circular battery ecosystem, actually domestically. So in that way, we are able to then contribute also to the overall European agenda. Next slide, please. So the background for this one is that, as mentioned, the sustainability. So we have a very fast growing wind power industry. There's a ample amount of new capacity coming online this year, about 1,000 megawatts, next year about 1,500, and so on. So the growth continues. So we are able to offer then the 100% renewable energy at one of the most cost competitive pricing across the Europe. And what is really unique is that we have one price area across the that then the companies can choose the locations based on let's say, very effectively. Then our grid reliability is essentially military grade, and that gives the stability also from the investment point of view, gives a benefit so that you don't need to build so many redundancy systems. So all this is then building, and we know that the 1 kilowatt hour battery capacity, that's about 100 to 150 kilowatt hours of the energy. So therefore, the energy pricing and CO2 free is also playing very nicely into the competitiveness of the companies. Moving on to the next slide, please. So in order to align our forces, we have done the national battery strategy. So we are big in sports, so we call this a playbook. And this is kind of play for the whole planet. So this is also available online, and more than happy, please copy it, steal it shamelessly, use it, so that we actually built this on the, let's say, across the Europe and for the world. Next slide, please. So our approach is very much this circular battery ecosystem. So as mentioned, we have the primary raw materials. From there on, companies are then building onto the battery chemicals, battery, let's say, advanced materials, cells, application. Application business is actually big one for us because that's essentially where the will be utilized. And we are not big on the EV side, but we are very big on the heavy duty marine side, which is also intensely being electrified. And then the reuse, recycling that are then emerging. But at the center is then the broadly the society, innovation, regional players, financiers, and also us as an innovation funding agency. So this is that we call Finland as a country club, but for those who know country club, so we have actually inclusive country club. So we are inviting then the players to come into this very broad, let's say, cooperative environment. Next slide, please. So, but we know that we cannot do this alone. So we are very pleased to see the activities that are taking place on the European level. Big credits to Mr. Šefčovič for his passion, drive, and drive especially for the results. And so therefore, this kind of building the overall value chain for the European resiliency and technology know-how build-up has been very beneficial. We have been contributing our share on the where we are strong on the raw material side, advanced materials, as well as on the recycling. And in that way, this has been very beneficial for overall, I would say, the European angle, but then also getting our ecosystem connected. So in that way, happy to see that the European level activities, there seems to be about 1 terawatt hour of the capacity build up on the battery cells. So now when we are joining the forces, we actually can build this together. And this is exactly what we are doing. So happy to contribute on that one. Next slide, please. So one thing that we should not forget is the battery research. And we know the technologies are moving very quickly. Finland, our strongholds are obviously on the battery materials. And then another end is the battery recycling. So where we have the European leading batch circle research collaboration. And again, happy to invite everybody to join into these ones, because I think this is also for the common good for the European angle. Next, please. So all this has kind of, let's say, the existing ecosystem, plus then also the working together with the multitude of the European partners and also globally. So there's actually an ample number of the investment by the decisions or announcements from the companies looking into Finland as a potential location. I'm not going to go through this one, but you can see based on the listing that this covers very nicely across the whole circular battery ecosystem, from the materials and all the way to the recycling. And again, we are encouraging the companies strongly also for the cooperation, building the value chain, because all this then will be benefiting us from the CO2 footprint point of view. Plus then also build up of the competencies, and all this is very nicely aligned with the European value chains. Next, please. So our focus is very simply the sustainability. I said that we are currently ranked in number one. We are not happy with that one yet. We want to and need to maintain that further competitiveness. We need to make sure that these industries remain competitive. So we are happy to talk about the cash flows, the net present values, and so forth. So that is then something that this needs to be competitive business. We know that there's a tremendous pressure from the investors and speed, scale, skills, skill side. We need to get the youngsters also into this because this is something we see that we do this with a purpose. We need to build the scale. So therefore, we have a, let's say, regions are preparing for this one. We have the grid preparations going on, and all this with the speed because the climate change is not waiting. So we need to build this capacity very fast. So to conclude, uh, how we see this one on the next slide. So our slogan is very simply that saving the world is a good business, and we want to do that together. And happy to contribute. And Marco, over to you, and happy to take any questions. Thank you.
Yeah, thank you, Marco, for your really comprehensive and interesting look into the Finnish ecosystem, the Finnish value chain for batteries, and your sustainability aspects. Yeah, again, just please type in your questions, and we will ask them in a minute, especially in 10 minutes after the next talk. And the next talk will be held by Yannick Mortieu. Yannick is working as a technical project manager within the cell development team of the business unit, battery technology and e-mobility at ElringKlinger. He has a master's degree in mechanical engineering and several years of experience in the automotive industry. And at ElringKlinger, he coordinates the development activities for an innovative lid design for lithium-ion cells, which will he now present to you and give you further insights. And additionally, Yannick is also an elected member of the IPCEI UBIT in facilitation group and responsible for facilitating the collaboration between companies involved in the workstream battery cell development. I'm really looking forward to your talk, Yannick. So the stage is yours, and then afterwards we have the Q&A. So please, Yannick, after you.
Thank you, Marco. Hello, everyone. As I was preparing for this presentation, I asked myself, how would our world look without batteries? And I came to the conclusion that the gentleman you see on the picture wouldn't be that happy because he wouldn't be able to cruise on his electric scooter, or he wouldn't be able to talk on the phone with his family and his friends. And I believe it's the same with all of us, that our world will look a lot different if we were not having batteries, because we have them nowadays in every areas of our lives. We have them in our phones, in our laptops, and more in our cars. So now coming to the next slide, we are currently experiencing the creation of several gigafactories in Europe. We are talking about almost 1,000 gigawatts hours, which are planned in the next 5 to 10 years. This in response to the increasing demand of battery electric vehicles. So when we do a short calculation, it brings us to find out that we will need approximately 2 billion battery cells and components. And this is a huge amount. That's why it's important to have a local battery value chain in Europe so that the transportation routes can be reduced to a minimum. So it's really huge what is happening at the moment right now. And coming to the next slide, we can see or we come to the point what is actually happening in those gigafactories. What they are doing is basically, among other things, also working on the development and production of battery cells. Battery cells come in different shapes: prismatic, pouch, and cylindrical. And in this presentation, I just want to focus on the prismatic cells because this is one of the most used in Europe. And one point that caught my attention is that every time we are talking about the battery value chain, most of the time at least, we see the battery system, we see the cell as a system, but we tend to neglect what are the cell components. Cell components are, for example, the cell lid assembly or the cell can, which are also really important when it comes to the safety or to the functionality of a battery cell. So ElringKlinger is focusing on the cell lid assembly. as a component, and it's an important part of the battery cell because it plays a key role. For example, protecting the environment against the cell chemistry which is harmful, or also protecting the cell chemistry against environmental influences such as humidity or things like that that can be harmful for the battery cell itself. So to make sure that we can reach those functions which are really crucial, we can go to the next slide, please.
Load more.
We at Ehringling are currently working at a new design, which is different from the state of the art in that way that we are going for a high function integration, which will lead to a material reduction overall the process. We are thinking about something like 50% material reduction, and of course then less CO2 emissions. So what we're doing here is that we are working on an innovative sealing with potting material. We are making sure that the single parts we are using have simpler geometries, which brings us also to the next slide, because when we are talking about the battery value chain or a sustainable design, it's not only about the design itself, but it's also about the production process. So what is behind this production process? What are we doing at Ehringling? We have a simple production process which goes from fast punching up to the transport to the customer. In between, of course, we have the washing, component assembly, welding, potting and drying, and the EOL packaging. And what is of utmost importance here is that we made sure that we reduce the production processes. For example, we are going away from the friction welding, which is a cost-intensive production process. We are trying to find new ways to join materials so that we can reduce the carbon dioxide emissions and also have the smallest possible production processes. And in that direction, we are definitely looking forward into working or collaborating with different material suppliers, equipment manufacturers, and cell manufacturers, because they are people who help us in this process of bringing a sustainable production process for our cell lead design. And that's what we are currently focusing on when it comes to the components cell lead assembly. Next slide, please. So when we look at that, we are currently active in the IPCEI, European Battery Innovation, where we are collaborating with companies which are active in the whole battery value chain, going from the raw materials production up to the recycling. Because for us, we have realized that it's important to be involved, to be an entire part of the battery value chain, so that we can support the gigafactories that are currently being built up in Europe, so that we can also work with people who are developing new cell chemistries, who are developing new battery cells. We want to be a support for those companies as well. We want to use the know-how of the equipment manufacturers to make sure that the battery value chain that is currently being established in Europe is a sustainable one, that we have a greener battery, and that we can be proud of bringing Europe forward when it comes to battery production, or when it comes to the battery value chain. Next slide, please. So Ehringling at a glance is we are active in the area of battery technology in several directions. If you wish to learn more about that, feel free to reach out to me via email or via LinkedIn, and I'll be glad to exchange some more words with you on that. So closing here, I just want to emphasize on the fact that cell component suppliers are to be seen as an entire part of the battery value chain, because it's not only about the cell as a whole, it's not only about the battery systems which are being installed in the cars. It's not only about the cell chemistry, which everyone is talking about, what will be the future, but it's also about the components that are actually helping to bring all of these parts together so that the cell can function at a high level and in a reliable way. So thank you very much for your time, and I'll be glad to respond to every question you might have. And back to you, Marco.
Yes, thank you, Yannick, for all. It is really nice overview of your work you are doing as an cell component manufacturer for the cell housing and the lids of a cell. Really interesting talk. And now I would like to invite Marco as well to the stage again for our shortly or briefly Q&A session. The next 8 to 10 minutes, we would like to answer your questions. So again, I just emphasize you to answer further questions in the chat or in the Q&A tool we got here at Excel Events. And maybe let's start with Marco. So first question, what are the shares of locally sourced raw materials in the Finnish industry? You mentioned that you also bringing in some raw material from outside Finland, but what are the shares of locally and domestic sourced raw materials in the Finnish industry for the material production?
Yeah, hey, thank you, Marco. Good question. And I think for very difficult actually to say because the numbers are continuously changing. And but our approach, these are the company's decision, but for us it's actually not important what is the share, but it's more important that we are able to, like I mentioned, that the sustainability, speed, and the scale, so that we are able to provide the raw materials for the cell manufacturing, and then also especially for the end users. So that is and then we know that the raw materials, they can come from the primary and the recycled. So both are then important. And so for us, it's that we are able to kind of build the platform that this processing of the raw materials can be done with the minimizing of the let's say the CO2 footprint. And obviously there we have, for example, Terrafame mine, and then now with the battery chemical production based on the bioleaching. So very let's say short transport distances, and all those are some of the things what we are now looking into, so that we are looking really holistically this sustainability and the CO2 footprint. So that is the kind of approach what we are taking on this one, rather than kind of what is the share. So we rather build the scale.
Okay, yeah, it's I think a good approach if you have such a good sustainability score as a number one. It's always good to be the number one. Marco, your camera is not on, or at least you have closed the lid. And perfect. Now we can see you all. Talking about lids, let's move. Perfect transition to Yannick again. And so we heard about a lot of recyclability the last days. Also the upcoming legislation by the European Commission. Do you also include the recyclability criteria to your cell design in a prismatic cell? And if yes, how do you do that?
Yes, of course, we're also thinking about the recyclability because it's also part of the Eubertin project we are working in. I think Maria Christina will say some few words about that later. What we are doing is that we are trying to reduce the amount of material used to a minimum possible. At the moment, we are using 4 to 5 materials for our cell lid assembly, and that speaks actually for the recyclability of our design. And we make sure we have in our cell lid assembly aluminum and copper, which can be regained after melting, after the lifetime of the product. And also what we focus on are the joining processes that are being used, so that we can separate the materials and recycle them in the most efficient way possible.
Oh, okay, good. Yeah, Thanks for that good answer. And back to Marco. One question from the audience. You mentioned material, of course. Recycling is a big aspect in Finland, but you mentioned the heavy duty activities. Could you elaborate a little bit more on Finland's activities in heavy duty ship transport? Which technologies are used there right now, and why?
Yeah. Hey, thank you. And I already sent a reply there, but maybe it didn't show up to everybody. But thanks, Mr. Unterkreuter, for the question. So, for example, I put there that one of the very recent ones is the ferry connecting Finland and Sweden. and it's a really let's say hybrid solutions there. So there's LNG solutions, there's a battery solutions, and multitude of others. So making it probably one of the most let's say CO2 friendly ways of commuting and transporting the passengers. So, but maybe I'll check that. I'll get the link also. So that's one of the samples. But then also that none of that can be done alone. So it's a wonderful combination of the let's say the new innovations and let's say the end users like a shipping line, and then multitude of the global technology providers who have then done this solution. Again, kind of good sample of that. This takes let's say a multitude of talent to build this one, but that is one of the examples.
Okay, yeah, great. Thank you, Marco. Coming back to Yannick, maybe you mentioned you just elaborated on your prismatic cell design and showed that you're also working on cylindrical cells, I guess. Are you also planning for locally sourced cylindrical cells as well by ElringKlinger? Because I guess the trend is now going more and more to cylindrical cells also in Europe, looking at different cell designs. So could you elaborate a little bit on your activities for cylindrical cells at ElringKlinger?
Yes, of course. Well, definitely we started with prismatic cells, and at the moment, or since this year, we are also working on a similar design for cylindrical cells, because as you said, they are coming more and more into the market. We are currently working with several partners also on the design for cylindrical cell, as I mentioned, and also we are looking beyond that. So also trying to work with institutions that are developing new chemistries or pouch cell to see how our design can be applicable to different cell designs. So prismatic cell, of course, is the one we started with, but we definitely are expanding or extending it to other cell designs.
Okay, yeah, great, thank you. I don't see any further questions from the audience. So yeah, let me just thank you both for your presentations and for your time right now and your Q&A session. I guess everybody can reach out to you afterwards during the conference or just by LinkedIn or mail. So at the audience, please do so if you have further questions to our speakers. And then let me thank you again for your time, and let's move on to our second block now in this session. We will now move on to the presentation of Professor Frans Dietrich. Frans Dietrich is since 2018 a full professor and head of the Department of Assembly and Handling Technology at the Technical University Berlin. He received his PhD at the Technical University Braunschweig in 2013, and afterwards he led the research group Assembly and Production Automation at the Battery Lab Factory Braunschweig. He authored more than 70 publications, received the Science Award of the Heribert Nash Foundation, and is involved in several patents in his fields, and will bring to you now the digitalization and essential paradigm for future manufacturing in Europe. So, Frans, the stage is yours, and we were happy to listen to your presentation now.
Yeah, thanks, Marco, for the kind introduction. I hope the IT works now. So my talk today is about digitalization in the battery production chain, and I want to give some thoughts and insights about the future directions that could be taken and that could be useful for both SMEs and larger enterprises. So next slide, please. So the basic thoughts from my opinion, digitalization in the battery value chain comes from is what can be improved. And I think one of the core problems or the challenges of that is that that flaws and failures take many processes until they can be detected. So this is a very simplified chart that I've shown here, but it transports like the idea. It says like whether an electrode is a good electrode or not cannot be detected earlier than after the electrode is finished, which means if there's something wrong at the powder or the coating stage, it needs to go through a few more processes until this can be detected. And whether the battery will be a good battery or not will only be detectable until the battery is fully assembled, which means that if one is not sure whether like a certain material with some certain outlier production result it can be made up to a useful battery, there's no other option than building the battery and see what the battery does, and that wastes a lot of value. And I think that is a core part where digitalization can come in and can help. Next slide, please. Thanks. So the basic idea of that could be to build a world of models, data or other digital representations, and pick up the parameters and the outcomes, the measurements that can be taken from the processes, which are all indirect parameters, put them into a model world, and then propagate that through simulation downstream to what the final battery might be. So that in a very early process step, one might predict the quality of the battery that might come out of a certain production, a certain concrete realization of the production here. However, the problem that we see is that the European market, there are many specialist players, SMEs, smaller companies, specialist champions, which are really focused and really deep into the technology in one or a few of these process steps. And there are, let's say, very few who are on that upper level to integrate all that into an ecosystem and into a consistent, let's say, turnkey modeling world, so that a complete chain of modeling and data representation world can be created. And I think that's a task for the future. Next slide, please. So when talking about models and data and digital representations, I think the left side is important to understand. So it is not only the product that needs to be a model, it's not only the process, it's all the equipment, it's aspects of the organization, it's also effects of the life cycle of a battery, in order to get a complete view about what happens and what effects in a very early stage of the process or in the product design may have downstream in, let's say, in the life cycle of that. So that's one perspective that needs to be taken into account. The other perspective that I see is, as Marco was addressing before in his talk, it's about the speed of innovation. So the pace is so high in innovation that the technologies will be substituted by other technologies, or many technologies are in development in parallel, and all of them are somehow supported by or elaborated by the use of models and data. And I think the world of digitalization of such models needs to grow as these technologies mature, from the very early ideation and lab tests down to the serious development or the operative production. So mainly when we see industrial modeling stuff, it's mainly about how getting the thing productive, but it's also in the labs where like the models are really deeply into. Next slide, please. So I think the digitalization in battery production, there is a lot of work to be done in 3 dimensions. The first dimension is what I would call horizontal digital integration, which means that models of each of the processes need to be connected in a daisy chain manner, so that just like the material flows through the physical processes, so that the data can flow through the models, so that the deviations from the nominal case that can be simulated through the models and then can be propagated through all the models in order to predict what kind of battery is going to come out if any of the parameters varies. The vertical integration that I'm talking about is a kind of aggregation. Not every perspective needs the same level of detail, meaning at the factory level, there is maybe not the full data needed. It's more about how to compute the models or the simulations very fast. So there need to be methods implemented to abstract the very detailed models and to aggregate multiple models into a perspective of a more abstract level there. And the third dimension I think needs to be addressed is the maturity, which means that models in very early stages, they need to be set up very fast, they need to be replaceable, they need to be modular, and the more the industrialization comes into the horizon, then the models will have less uncertainty. They need to have more thorough checking and more thorough prediction quality. And I think that needs to be addressed all in the models, in the model structures, but also in the way the models are worked with. Next slide, please. So what are the objectives and techniques of digitalization? When we talk to different people from industry, it's about faster process development, faster innovation, faster troubleshooting, faster ramp up. It's also about modularity and replaceability. Say one supplier is a specialist for one of the processes, and they want to integrate their processes into a whole chain. It's about the modularity of the process and how to say how can that be integrated modularly into the whole process chain. And I think digitalization can be a helper for that. And the modeling techniques, I think they can be grouped into 4 groups. The first group is modeling techniques that are directed towards visualization and communication, towards analysis and prediction, towards control and decision, and towards learning and optimization. And you can see not everywhere is AI in there. I think still there's a lot of room for, say, all the other really powerful modeling approaches there, and they are needed there. Next slide, please. I'd like to show some examples that we are doing when working on at TU Berlin. When I stand here, like I'm a representative for the whole research network at TU Berlin. We're doing materials, we're doing modeling, we're doing design, processing, business models, and my team, we are a lot into cell production, which means assembly, end of life, and digitalization of the whole chain. And I'd like to show you 3 short examples of these digitalization things. Marco, how many time do I have left?
2 minutes.
Thanks. That's okay. Thank you. Okay, next slide, please. So you will see some QR codes. So feel free to follow us up on that video and the papers. So that's is that. So here's a kind of visualization. So we're developing a kind of fast stacking process here, and the process kinematics is quite complex. And whenever we need to onboard people to the project team, or when we want to communicate this to customers, we have developed a kind of app we can use in an augmented reality style. And you can see that video here, where we can visualize what we mean when we talk about our process or any detail or any models of that. Next slide, please. So the second thing is about analysis and prediction. This is a process from destacking and acceleration of electrodes. We have developed a process which accelerates the electrodes very reliably, and we have done modeling and simulation to check the mechanical loads on the electrodes here and to optimize the gripping system and the gripping process here. And the models in the background, they can still be used then to troubleshoot or when new material comes along, so to adjust the machine to new materials in a very fast time. Next slide, please. This is another example here where we use the model-based principle to develop a machine and a process for on-the-fly alignment of electrodes. So electrodes are traveling with 1 meter per second or faster through the machine. And we have very simple sensor equipment in there. And we have models who predict the accuracy and who predict the compensation that is needed to insert the electrodes on the fly at the final destination. Next slide, please. So the last example that I wanted to show is about the complete machine that we are building right now and setting into operation. So we have about around 10 modules for 10 processes in there. and we use the connected models for that because it is necessary to achieve the final accuracy of the battery assembly. For example, we have kinematic models that we can use in order to determine where are the sensitivities and where to tune when the accuracy does not fit. Next slide, please. So the key messages that I wanted to send is that I'm convinced that digitalization is a key thing for small and medium enterprises to help get like their share in the market, to integrate them into that. I think for the larger enterprises, we see activities to create ecosystems to integrate such specialist models, and I think as a whole, this facilitates the roadmap to having complete turnkey suppliers for that. So thanks for the time, for attending. Thanks for you all. I'm really keen to learn about your questions. Thank you.
Yeah, thank you, Frans, for this interesting and really visual presentation. And we will have the Q&A session just after the next talk, which will be our last talk, held by Maria Cristina Pasi. She's the founder and managing partner of an applied science consulting firm, ISA. I hope I pronounced it correctly. Otherwise, you can correct me, Maria Cristina, in a minute. With chemical enterprises, research and high-tech startups. Maria Cristina is in the Oil BID project implementation manager at Italmatch Chemicals and senior advisor within the company's ESG division. Currently, she's actively engaged as a leader of the workstream Recycling and Sustainability in the BID IPCEI, bringing her 30 years experience in the context of specialty chemistry, industrial advanced technologies, and water management to the implementation of the IPCEI goals. So Maria Cristina, the stage is yours, 10 minutes, and then afterwards we have a Q&A session. Yeah, we're looking forward to your talk. Please, after you.
Thank you, Marco. So this talk is about closing the circular loop of batteries with a specific focus on manufacturing batteries in a systemic circular value chain, which is characterized by two fundamental pillars, which are sustainability and recycling. Next slide, please. The battery value chain, as it is intended within the European Battery Innovation IPCEI initiative, is definitely a strategic value chain, where, next slide, strategic value chain is defined officially as a value chain which has a systemic importance and makes a clear contribution to the European Union growth by implying contemporarily technological innovation, economic and market potential, as well as societal and political importance, which is not exactly the state of the art within the European context. In spite of plenty of R&D technological innovations, chemical, physical, and engineering innovation, these were not sufficient to enable a proper installment of an industrial sector within Europe focused on electric vehicle batteries, at least so far. And secondly, in spite of a huge market and economic potential represented by the European Society of Consumers, there are no battery cells production sites able to satisfy the domestic European demand and also able to satisfy the future envisaged demand from beyond Europe. And last but not least, there are no eco-sustainable business models at the moment within the battery sector, which can provide the proper societal and political benefits in terms of integration among the ecosphere, the technosphere, and the house sphere of our integrated system. We live in a world in which a system to be sustainable has to be integrated. And this integration has to be in equilibrium, in a balance, in order to guarantee a proper and sustainable growth from an economic perspective, but with the protection of all our resources. Next slide, please. And this European battery innovation value chain within the battery sector is a systemic one as well, and we will show you why, because it aims to reach the objectives of the development of a sustainable battery with a battery passport by protecting as well the primary resources capital, as well as the land capital, the energy capital, and the materials capital within Europe, and I would also say beyond Europe, because we all know that whatever we do in a systemic system, whatever we do in a specific location has a massive effect not only within a specific territory, but worldwide. And let me introduce to you also the economic mission approach, which is an innovative economic model that has been adopted by the European Union within the development of the future European industrial growth strategy. The economic mission approach model is based on the fact that all these parts of the systemic value chain in which we all live have to be integrated at technological level, economical level, as well as financial level, and also industrial level. And let's go to the next slide to see this concept even better explained. We see on the left side that all the factors which are characterizing the mission, the mission-based economic approach are a systemic, let's say, assembling of financial issues, environmental issues, energy issues, and economic issues. And this is, of course, in favor of circularity characterized value chains, not only within the battery sectors, but within all the industrial sectors. Because to get a circular value chain, we need to guarantee circularity at any level, also within these stages in which circularity is not profitable, where we don't see any short-term economic results, but the stage is anyway indispensable in order to develop a sustainable circular systemic value chain. And the aim of the European Battery Innovation IPCEI2 project is definitely to generate a battery value chain which is circular itself from material extraction to recycling, but in addition to this circularity and complementarity, circularity and recycling and sustainability has to be guaranteed within each of the stages. And I thank much Yannick because he could show in his presentation that at the level of cell components manufacturing, we need to guarantee circularity and sustainability, as well as we need to provide sustainable solutions in the material extraction, in the material production, as well as in all the other stages. So let's go to the next slide. And here we have an additional example about the systemic circularity and complementarity features of the European battery value chain. We see that also from a geographic perspective, and also in the name of an homogeneous and balanced growth all around the territories, the 4 work stream clusters in which the 46 partner companies are acting are nicely distributed from south to north, from east to western part of Europe. And we see that there are many different nodes which are connecting the different clusters and the different companies, saving competitiveness, and also competition, but at the same time providing innovative solutions which are of support to the other cells, to the other stages of the battery value chain. I would like you to focus your attention on the nodes between the recycling and sustainability cluster of the companies and the raw and advanced materials, which is really the strategy, the core strategy of the European battery value chain. You know all better than me that we are very poor in primary resources. And even if we were rich in this, there is a green issue which obliges us to reuse raw materials instead of exploiting the natural resources, which are not infinite. If we think about phosphorus resources, if we think about lithium, manganese, cobalt resources, they are not only far away from Europe, but they are also finite resources. And if we think about the envisioned development of the electromobility, actually, these resources won't be enough to feed the value chain. And then, going to the last slide, let me summarize our strategic value chain within the European battery sector, which gives you a clear idea about the strategic value, because you can see that in all the different stages, from raw and advanced materials to the recycling, the different stages are providing to the European citizens, to the European market, to the worldwide market, technological innovations, economic and market potentials, which are not only within the battery sectors, but that can be also spillover effect into other sectors, and also societal and political gain. If we focus on recycling, we see that also recycling is having a specific value. It is becoming a profitable stage of the value chain, and it is not only to be followed for environmental issues, but because it can be the leverage of additional technological innovation, economic and market additional potential, as well as societal and political benefits in the protection of the resources. I thank you all for your attention.
Yeah, thank you, Maria
Cristina. I leave you the
Cristina.
floor for the questions.
Yeah, perfect transition. The floor for questions is now open. Please type your questions in. I invite again Frans and Maria Cristina to turn on your cameras. You already did. Okay, let's just start. One questions coming in from the audience for Professor Dietrich. How do you see digital integration playing a role in the assessment of battery packs at end of use in the second life applications?
Yeah, thanks, Mr. Barnes, for that question. I think there is no black and white answer. From a perspective of an entity who wishes to do recycling and generate money with that, and from a societal aspect, I think it's very helpful. The more data that can be available at that point of time, the better. From a original equipment manufacturer, it's maybe not so much of interest, because to implement that and to generate the data, to store the data and make the data available, that will be a substantial effort. So I think the digitalization at the end of life will be a compromise of maximizing the amount of data and the clarity of information, and minimizing the effort for that, and to infer that with the measurement and testing data that can be gathered at that point of time. I think it's not answered yet, and we will see in the in forthcoming years how the regulations and how the markets will develop in that point.
Okay, yeah, thank you. Maybe one question to Maria Cristina also going into this recycling aspect, what do you think are the biggest obstacles for efficient and circular recycling right now? Is it more the technology, or is it the logistics of getting the cells back to the recycler?
It's a big question, actually, because both the factors, technological factors and logistics factors, are affecting the recyclability of the components. Technological factors are related to the yield and the efficiency of the existing recycling processes. And this has obviously an impact on the cost of recycling, as well as an impact on the type of reuse of the components which are recycled. So there are definitely some technological barriers which can be, let's say, overcome by developing new technologies, innovative technologies, and also taking technologies from other sectors and adapt them to the battery recycling. And on the other side, there are also logistic barriers because we need to have recycling close to the components manufacturing. When we speak about recycling, we don't have to think only about the recycling to get new secondary raw materials. We have also to think about second use by disassembling properly the batteries. In this, digitalization can be of great help, because if we have a battery passport, it is possible to recognize which can be the components that can be reused and where they can be reused. And there are many projects within the IPCEI dealing with these thematics. Also from a technological perspective, let me say that recycling could have a huge potential if we think about the recovery of strategic raw materials from existing wastes, which are not only coming from the battery sector, but also from other sectors. For instance, we can think about the recovery of phosphorus, which is a strategic elemental raw material for the development of liquid electrolytes. Phosphorus can be possibly recycled as an elemental material from the recycling of the organic and the urban and industrial wastes all around the world. Mm-hmm. So really, it's a mixture of logistic issues and technological issues.
I would like a lot to tackle.
Yeah.
I don't want to interrupt you, but I have one really urgent question to Frans from the audience again. So I don't want to interrupt you, but maybe jump to Frans again.
Please.
You showed us this analysis and production system you're using at the TU Berlin. Could this also be used for like checking the quality of aluminum or copper foils? And yeah, are those systems now key at this level as an inspection system? And also looking into those inspection systems in your research area?
Yeah, okay. I think there's a number of questions in what you asked. I think the first thing is about like the experimental, the experimental quality detection, like the physical detection, which is not very much about modeling or digitalization. It's like, say, like metallurgical experiments that need to be carried out. So I think, yeah, that could be done by an experimental thing. As soon as we know more about what happened to the material, one could attempt to model that. But it's hard to judge whether that will work over a long lifetime, because it depends on the uncertainty in the input variables that can be gathered from historical data there. I think there's no clear answer to that at the moment. Yeah, could be feasible, but don't know yet.
Okay, yeah, thanks, Frans. So we are already at the end of our session. So maybe just to wrap up everything, first of all, I would want to thank all of the speakers for attending today, also the audience for attending to speak in this session. Yeah, all the cameras are going on again. Yeah, thank you, Marco. Thank you, Yannick. Thank you, Frans. for this interesting talks. I guess everybody is still available for answering questions or for contacts during this event series today and tomorrow. And maybe one thing, if you still want to know more about the BID2021 we have a booth here at the Battery Innovation Days. So feel free to come around, look at our things we are doing right now for the ecosystem of the battery Europe-wise, and we are happy to answer your questions in the upcoming days. And again, thanks for all the speakers, and thanks to the team behind the team also. And we are looking forward to the next days and hope to see you all during the expo, which is now starting. So thanks again, all of you, and happy to see you in the upcoming days.